Welcome to the DIY Honda Garage channel. DTC P2176 refers to a diagnostic trouble code associated with the throttle actuator control system in the Honda CR-V model years 2011 to 2016. This specific code indicates that the system has not learned the idle position of the throttle actuator, which can lead to various performance issues. The throttle actuator plays a critical role in regulating engine airflow and maintaining optimal engine performance. It is located in the throttle body assembly of the vehicle, which is upstream of the intake manifold. When the engine control module, or PCM, powertrain control module, does not receive the appropriate signals indicating throttle position, the code is triggered. This failure can impact vehicle acceleration, idling speed, and overall drivability. The throttle actuator control system is a vital component of your Honda CR-V's engine management system. Its role is to adjust the position of the throttle valve, which controls the air intake entering the engine and thus influences the engine's performance and power output. Specifically, the throttle actuator is located in the throttle body, which is connected to the intake manifold. When the accelerator pedal is pressed, the PCM sends signals to the throttle actuator to open the throttle valve, allowing more air into the engine. If the PCM does not confirm that the throttle actuator has learned its idle position, it triggers DTC P2176. It is crucial to understand that a malfunction here can lead to poor acceleration or erratic idling behaviors. Proper diagnosis is necessary to ensure that the vehicle operates smoothly and efficiently. When analyzing the potential causes for DTC P2176, several key factors need to be considered. One primary cause could be a faulty throttle body that may have internal malfunctions preventing it from operating correctly. Another possibility is poor electrical connections, either at the throttle body itself or at the PCM. These connections can corrode or become loose, leading to disruptions in signal transmission. Furthermore, a malfunctioning PCM or outdated software could mistakenly interpret the data received from the throttle actuator. It is essential to perform a thorough inspection to identify these issues effectively. Each of these components plays a specific role in the operation of the throttle actuator system, making understanding their function critical for accurate troubleshooting. Identifying the symptoms of DTC P2176 is crucial for timely intervention. One common symptom is erratic engine idling, where the engine revs fluctuate unpredictably when the vehicle is at a standstill. Another notable issue is poor acceleration. Drivers may notice a lag in throttle response or the inability to reach higher speeds smoothly. Additionally, the malfunction indicator lamp or check engine light on the dashboard will likely illuminate, notifying the driver of a fault in the engine management system. These symptoms should prompt immediate diagnostics, as ignoring them could lead to more severe engine performance issues. Recognizing these signs early can help maintain vehicle reliability and performance. The first step in troubleshooting DTC P2176 involves ensuring the ignition switch is turned to the on position. This action powers the vehicle's electrical systems and allows the diagnostic tools to communicate with the vehicle's onboard computer, specifically the HDS or Honda Diagnostic System. After this, you should clear the DTC using the HDS, which resets the system's error logs. Following the clearing of codes, the ignition must be turned to the lock 0 position for a moment before switching it back to on 2. This process enables the system to recognize any existing pending or confirmed DTCs. Checking for these codes is crucial. If P2176 or any related DTC appears again, it indicates that there is an unresolved issue that needs further investigation. On the other hand, If there are no codes, it may suggest an intermittent failure or a loose connection. In this step, turn the ignition switch to lock 0 to ensure all electrical systems are powered down before any disconnection. Next, disconnect the intake air duct from the throttle body. Removing this duct allows for direct access to the throttle valve for inspection. Now, it is essential to turn the ignition switch back to the on to position to enable diagnostic checks. With the HDS, perform the Electronic Throttle Control System (ETCS) test, which evaluates the throttle valve's operation. You'll want to visually confirm whether the throttle valve moves to its fully closed position. This step is integral. If the throttle valve does not respond correctly during the test, it is likely that a fault exists either within the throttle body assembly or its control circuitry. Making this visual confirmation can direct the next steps of the diagnostic process. This step begins by turning the ignition switch to lock 0, ensuring safety before accessing internal engine components. The next action involves removing the throttle body, which may require specific tools and cautious handling to avoid damaging any surrounding components. Once removed, inspect the throttle valve closely for any signs of carbon buildup. Carbon buildup can restrict the valve's movement, directly leading to issues such as inaccurate throttle position readings, and thus triggering DTC P2176. If carbon deposits are present, cleaning the throttle body will be necessary to restore proper airflow and functionality. If no carbon buildup is detected, this indicates a deeper issue, possibly requiring throttle body replacement. Knowing how to differentiate between these two scenarios can significantly impact repair decisions. In this step, begin with turning the ignition switch to lock 0 to ensure that the vehicle systems are powered down for safety. Following this, you will jump the SCS line and using the HDS, which facilitates a controlled diagnostic flow for electrical checks. Disconnect the PCM, Powertrain Control Module Connector C, and the Throttle Body 6P connector to isolate the circuit being tested. Using a jumper wire, connect terminals A and B on the Throttle Body 6P connector. This setup will allow you to check for continuity between specific test points. Point 1 at the PCM connector C and point 2 at the throttle body connector. A continuity check ensures that the wiring from the PCM to the throttle body is intact. If continuity exists, then the wires are functioning correctly. But if not, it indicates that there is an open circuit, necessitating repairs or replacements in the MTR1 or MTR2 wires. Once repairs are complete, final verification is crucial to ensure that the system operates correctly. Start by turning the ignition switch to lock 0, and then reconnecting all the connectors that were previously disconnected during troubleshooting. After that, turn the ignition switch to on in order to bring the vehicle systems back online. The next step involves resetting the PCM, which allows the computer to reinitialize and adapt to any new components or configurations made during repairs. Following this, conduct the PCM idle learn procedure, which is essential for recalibrating the throttle actuator. This process establishes the throttle's initial reference point for the engine control module. Finally, after waiting a sufficient time, check for any pending or confirmed DTCs once again to confirm the success of the repair. Successful completion of this step means the vehicle can now perform efficiently without displaying the P2176 code. Preventive maintenance plays a vital role in avoiding the recurrence of issues like DTC P2176. One effective measure is to regularly clean the throttle body, as carbon buildup can develop over time and affect throttle performance. Cleaning should be performed according to the manufacturer's recommendations, typically during regular service intervals. Additionally, inspecting the electrical connectors to the throttle body and the PCM helps ensure that connections remain secure and free from corrosion. It's beneficial to engage in this habit during routine checks to avoid potential signal loss that can lead to error codes. Updating the PCM software when updates become available is equally important, as software improvements often enhance system performance and resolve known issues. Implementing these practices ensures that the throttle control system operates smoothly, reducing the likelihood of future problems and enhancing overall vehicle reliability. In conclusion, DTC P2176 is a specific code related to the throttle actuator control system that indicates an issue with the idle position learning. Understanding the role of the throttle actuator and its integration with the PCM is crucial for proper diagnostics. Thoroughly checking both mechanical and electrical components can identify potential failures effectively. Moreover, it is equally important to perform regular maintenance to avoid issues like carbon buildup and electrical connection failures. Following the troubleshooting steps diligently ensures accurate identification of the root cause, leading to an effective resolution. Ultimately, maintaining awareness of this code and its implications helps enhance the vehicle's overall performance and longevity. Please like and subscribe to the channel. See you next time.